Hello students, myself Manasa J. I am working as Assistant Professor in the Department of Chemistry at HPPC Government First Grade College, Chellakere. In this video, I am going to discuss about metallurgy and extraction of nickel. Metals have generally low ionization energies, low electron affinities and low electronegativities, which are responsible for their high electrical and thermal conductivities, high malleability, ductility, metallic luster and hardness. Hence, they have been used widely by man since ancient ages. Metals occur in nature, sometimes free but mostly in the combined state. The Earth's crust is the biggest source of metals. Some soluble salts of metals are also found in seawater. Noble metals like silver, gold and platinum occur in nature in native state along with the alluvial impurities. The active metals occur in the form of their compounds. These compounds are known as minerals. The minerals from which metals can be conveniently and economically extracted are referred to as ores. Let us know what is metallurgy. Metallurgy is the process of extracting metals from their ores. The metallurgical process would necessarily depend upon the nature of ore which is to be worked out for the extraction of a particular metal. It is not possible to chalk out a universal scheme for the extraction of all metals since the extraction of each metal involves individual procedure depending upon its nature and properties. Let us know the steps involved in metallurgy. The first step is crushing and grinding. It involves crushing of ores into a fine powder in a crusher or ball mill. Second step is the concentration of the ore, also called as dressing. This step involves removing impurities from the ore. It can be done by any of these methods: hydraulic method, magnetic separation method, froth flotation method, gravity separation method, leaching method or chemical method. Next step is working up of the concentrated ore. This involves obtaining metal from the concentrated ore. The procedure followed depends on the nature of the ore and the metal. Next step is purification or refining of the metal. It is done by any of the following processes: distillation process, bessemerization, Van Arkel process, zone refining, electro refining, poling, parting, etc. Let us know about the extraction of nickel. The chief ores of nickel are pentlandite, nickel glans, garnierite, limonite, etc. The principal ore of nickel is pentlandite, which is a sulfide ore. Let us know about the steps involved in the extraction of nickel from pentlandite. The first step is crushing and concentration of the ore. The ore is crushed in big jaw crushers and then finely powdered in ball mills. It is concentrated by froth flotation process using water and pine oil. The second step is roasting. The concentrated ore is roasted in air. Iron sulfide is oxidized to ferrous oxide and sulfur dioxide. Copper and nickel sulfides remain almost unaffected. The reactions involved are 2FeS plus 3O2 giving 2FeO plus 2SO2 and S plus O2 giving SO2. The next step is smelting. The roasted ore is smelted with coke, quartz and some limestone in a blast furnace. Most of the unreacted iron sulfide is converted into ferrous oxide. The reaction is 2FeS plus 3O2 giving 2FeO plus 2SO2. Ferrous oxide combines with silica to form ferrous silicate slag. The reaction is FeO plus SiO2 giving FeSiO3 slag. Lime removes silica as calcium silicate and the reaction for this is CaO plus SiO2 giving CaSiO3 slag. The fusible slag can be removed easily. The fourth step is Bessemerization. The molten matte is transferred to a Bessemer converter lined inside with a refractory material like magnesium oxide. A blast of sand and air is blown in when the sulfur is oxidized to sulfur dioxide and the iron to ferrous oxide. Ferrous oxide combines with silica to form ferrous silicate slag which is skimmed off. The Bessemerized matte consists mostly of sulfides of copper and nickel with traces of iron. The next step is conversion of Bessemerized matte into pure nickel. The removal of copper and subsequent conversion of the matte to pure nickel is known as refining of nickel. Refining can be carried out by any of the following processes: Mond's process, Orford's process, electrolytic method, German process, etc. Let us know about purification of nickel by Mond's process. This process involves the following steps. First is roasting. The Bessemerized matte is roasted again to convert sulfates of calcium and nickel into their respective oxides. The reactions are 2NiS plus 3O2 giving 2NiO plus 2SO2 and 2CuS plus 3O2 giving 2CuO plus 2SO2. Next step is leaching. The oxide mixture is treated with 15% sulfuric acid at 353 Kelvin, which dissolves most of copper oxide, leaving the nickel oxide practically undissolved. The solution is then evaporated to obtain crystals of copper sulfate, which is a byproduct of this process. The reaction is CuO plus H2SO4 giving CuSO4 plus H2O. The next step in the Mond's process is reduction. The residue containing nickel oxide is heated to 573 to 623 Kelvin in a current of water gas. Water gas is a mixture of carbon monoxide and hydrogen gas. Nickel oxide is reduced to the metallic state by water gas. The reactions involved are NiO plus H2 giving Ni plus H2O and NiO plus CO giving Ni plus CO2. The next step is volatilization. The finely divided metal is kept at a temperature of 323 to 333 Kelvin and a current of carbon monoxide gas is passed over it. The nickel forms a volatile nickel carbonyl which has a liquid boiling point of 316.2 Kelvin. The reaction is nickel plus 4CO giving NiCO 4 times. The next step is decomposition. The gas charged with nickel carbonyl vapors is lead over granulated nickel maintained at 423 to 453 Kelvin. The carbonyl coming in contact with heated granules undergoes decomposition, depositing its nickel or granules which grow in size and are continuously removed. The reaction is NiCO4 giving Ni plus 4CO. The carbon monoxide released is used again for further carbonyl formation. Nickel obtained by this process is about 99.9% pure. Let us know about uses of nickel. Most of the nickel produced is used to make ferrous and non-ferrous alloys. Nickel improves both the strength of steel and its resistance to chemical attack. Stainless steel may contain 12 to 15% of nickel, and steel for cutlery contains 20% chromium and 10% nickel. Very strong permanent magnets are made from Alnico steel. The mnemonic series of alloys 75% of nickel with chromium, cobalt, aluminum and titanium are used in gas turbine and jet engines. Nichrome contains 60% nickel and 40% chromium and is used to make the wire in electric radiators. Cupronickel 80% copper and 20% nickel is used to make silver coins. The nickel silver containing roughly 60% copper, 20% nickel and 20% zinc is used to make imitation silver articles. These are the references which I have made use. Thank you.